This question, they gave us a function. They want to know the absolute max and min. So to do that, we got to take the derivative. I would rewrite this as 28x to the minus 1. It's going to make the derivative easier. So then we'll take the derivative. This 1 power comes down. Oh, and then the x is gone because we subtract 1 from the power. Minus 28 because that minus 1 comes down. X to the minus 2 because subtract 1 from the power. And then we set it equal to 0. That's the first step. To find an absolute max or min, we step number one is to take f prime and find out what'll make it equal to 0. And those, when you find those are called your critical values, your important places to look. I'm going to solve this equal to 0. You set it equal to 0. So now I'm going to jump this 7 to the other side. So then I'll have minus 28x to the minus 2 is minus 7. Okay. Then I'm going to make this minus 28 over, oops, it's a little better, over x to the positive 2. What just happened there? Remember, negative powers jump down and then become positive. Negative powers are negative, like somebody negative at their job. They're unhappy where they're at and they want to jump to the other side, then they become positive. Now, how do I solve this? We'll put this over 1 and go diagonal, diagonal, cross multiply. So we get, a little more room here, negative 28 times 1 is negative 7 times x squared. So that means negative 28 is negative 7x squared. Divide by minus 7. And what's that? Positive 4 is x squared. All right, root it, root it. Don't forget, plus or minus, whenever you put a root on roof on the house, got to go up and down the ladder, put a root on, you got to go plus or minus. So plus or minus 2. Those are my critical values. Critical values. Plus or minus is all that. We take the derivative equal to 0, solve for the critical values. And now we got to plug those in. Now, um, this is the left edge, 0. And the right edge is actually, there is no right edge, it goes forever. So what you do in step two? So step two, after you find the critical values, you make an x, f of x table, and you plug in x is the left edge, x is the right, if you have one, we don't have one, and then x is all the critical values. One at a time, and you get your f values, and you take the biggest and the smallest. That's basically it. So let's do it. So I'm going to come over here and make a table. X is going to be here. F of x is going to be here. What is f of x? Our original function. 7x plus 28 over x. 7x plus 28 over x. I'm going to plug in the x. What did we get? Our left edge, go back up there again. Our left edge is 0. The right edge is infinity, so there's no right edge. Left edge is 0. So let's start with the left. X is 0. And then we don't have a right edge, but then we have a critical value and a couple of them, but I'm only going to do the plus 2. Why is that? Well, because the minus 2, right? We had plus 2 and minus 2. Minus 2 is outside of the 0 to infinity range, right? They told us to go from 0 to infinity. See up here? It said go from 0 to infinity. So that means no negatives. So throughout the negative 2, he's outside the range. So I'm just going to check the left edge 0 and the critical value 2. I'm not going to check negative 2. It's outside the range. Not, you can't do infinity. That the right edge just goes forever. So plug it in. Plug it into the function. And you plug in 0 there. What do you get? You get 7 times 0 is 28 over 0. That is undefined. You can't have 0. Oh, yeah. That's why it said greater than 0. X is on the wide side of 0. So you can't be right at 0. That's undefined. So forget about that. Plug in the 2 now. So now we'll plug in the 2. Oops. Looks like my pen's having a little trouble. So I'm going to plug in the 2 here. And when I plug in the 2, I'm going to find my critical value. So here we go. Mm, mm, Looks like my pen is not wanting to do it. Let me charge 1 second. So just plug in the 2 right there, and you will get your last value. So let me do that.